Hello, everyone. Thanks for joining part 2 of our Advanced Manufacturing webinar series. My name is Nick Norzinski at D3 Technologies, and today we're going to take a look at programming your B and Y axis turn milling centers with FeatureCAM. So just a little bit of background on FeatureCAM. It is a feature-based CAM system, meaning it's automated based on features as opposed to generating each toolpath individually. It's the most comprehensive machine solution that Autodesk has to offer. I'll show a list of all the different supported machine types at the end here. We reduce programming time and produce consistent results through machine configurations and attributes, which are files that can create defaults for your operators from programmer to programmer to have consistent and repeatable programming solutions. It is the fastest programming package on the market. So using feature-based and automation with the different wizards and feed and speed libraries and tool libraries, a lot of that process is automated, as you'll see. So what is a feature? A feature on the left here in the milling part would be like a pocket, a hole, a boss, a side feature. On the turning side, you get your turn profile, your grooves, your side, and board holes. Those are just some examples. So within side of FeatureCAM, you're going to be able to program your parts faster using feature-based by just importing, identifying and creating those features, simulating those, and then with the simulation, it's going to generate the G code or the NC file based off the post you have selected. So how does this look in a traditional CAM workflow? You draw or import the part, you create a setup, then you go ahead and select the type of toolpath you're creating, select where you want to cut it, select the type of toolpath, pick your tool, pick your feed and speed, select your parameters for cutting, your step over, your step down, etc. Then you simulate and you generate the NC code. All 6 of these steps are going to be repeated for every single toolpath. With process-based CAM and FeatureCAM, we draw or import the part, identify the features, select the machine processes, and the toolpaths are automatically created based on those machine processes. And then you simulate, and in the process of simulation, like I said, the NC code is created. So after that's done, you can go back and see if it's the correct tools, if the process has the correct feed and speed, step overs, and things like that. So with a comprehensive machine solution in FeatureCAM, we have the ability to program 2.5 axis, 3, 4 axis, 3+2, 3+1, 5 axis, and mill turn within the milling environments. On the turning side, we support turn mill up to 4 channels, so 4 turrets, Swiss type with part maker that also comes with FeatureCAM. Simple 2-axis turning, some probing operations. You can do production with tombstoning or tombstones and fixturing. And on the wire EDM side, we support 2 and 4 axis. So for today's class, webinar, we're going to take a look at using feature recognition for turning operations. So we're going to first take a look at automatic feature recognition, then we'll look at interactive feature recognition. Then we'll look at how to program your Y-axis live tooling versus C-axis, and then programming your B-axis on turning and milling as well. So there's our contact information, and we're going to take a look at the software. So this first part here, we're going to take a look at how to apply automatic feature recognition. So this is going to take a look at the model. You can see here I already have the stock defined in red. I've got 2 setups here, so we mill or turn one side of the part, turn it around, and then turn the other side of the part. I've got a Haas SL machine selected, and for the stock, we are just doing aluminum for this part. So that's where the feeds and speeds and tooling is going to be based off of. So how this works, we select AFR. It's going to look at setup 1 first. It's going to do a bore, face, hole, turn. Then on the second side, it's going to do, it looks like the same ones, but we don't want to rebore and we don't want to redo the hole. So we're just going to select the face and the turn. And we'll say finish. I can move over to 3D simulation, play that out. And as we simulated, it ran through that post and generated our G code. So just like that, running AFR in the part, selecting the ones we want to keep, and playing out the simulation is going to get us right to code. Now there was a couple things I would probably change here. We want to have some room to chuck the part, so I would only turn probably to here on one side, and then flip it over and turn only to here on the second side. So that's an easy enough change to just go into that turn feature. Here I can have, or here you can see I have two operations on that one turn feature. And I'm just going to set a boundary on the spindle side to stop there. And I'm going to do the same thing on the second side. Specify a spindle side boundary for setup 2 to stop right here. So we got a little bit of overlap. We got room to chuck the part. And I think that should be it. We'll slow it down just a little bit this time. So you can see it face, turn on setup 1. Pre-drill, looks like there's a little peck cycle there, finish bore, face the second side, come back and turn that side, and we are complete. And here you can see we had two different setups. I've got I think I have G54 specified for the first side, and I believe I put G55 for the second side, so you could have two different work offsets there. All right, so that is automatic feature recognition, and now we'll move to this part, which is got a little bit more going on. We've got some milled features, radial and axial. There's an axial one. And so we're going to start off the same way. We've got two setups here. I'm going to change from a Haas to a Okuma. We'll do the Multis. I got a B400. So I'll select that. And I got my tool library loaded. All right, so first thing I want to do is select the setup we want to start with and run through AFR again. So here we're just going to run through and automate what we can, and then we'll come back and add some other features with IFR. So we want to bore, we want to face, we want to do these holes in the outside of the flange. There's a side feature there that tries to go around the whole part, but that's actually only a little cutout right here. So we're going to do that one differently. We're going to exclude that. And we do want to machine around that flange, and we will turn. So we'll keep all the rest of those. And then on setup 2, this is just saying it may not have found everything, which is fine. We're gonna add what we can from AFR. So on side 2, we do want to bore that one as well and face. We've already got the holes, so we don't need those. We don't need to do this flange side again, but we do want to turn that side. All right, so I'm going to now hide my features just to get rid of this purple here. And so first thing we want to do, let's make sure that we stop our turn here. So we got some room to chuck the part again before we turn it around. So I am going to come into that turn feature and do what we did in the last part. We're just going to set a spindle side boundary to stop right there. And you can see it stops there in blue. We'll apply that and okay. And then on the side feature, I don't want it to cut all the way to the back of the part. So I'm going to come in here, and maybe I don't know the depth. I don't have a blueprint in front of me. I can just simply measure and Z what I want to do. So it looks like the flange is a 1/2 inch. We'll just add another 50 thousandths past there just to make sure that we get everything. And okay, that. And so at this point, if I do a 3D simulation, we will probably see we get a gouge here. And I've got my pause on gouge turned off because I do a lot of post work, and with posts, I'm just wanting to get to code. I'm not too worried about if there's a collision or not. I'm just looking for code. So here I can see that gouge has happened. So to get rid of that gouge, we need to drill the hole before we come with our boring bar. So I'm going to eject this and come into that boring bar. I could create a hole feature, but with feature-based CAM system, I can just go to the strategy tab of this bore operation and specify I want a pre-drill hole before it comes in. So I'm going to do a 875 and a depth of looks like 3.5 inches. So we'll apply that, and we're going to do the same thing on the second side. try to use minimum amount of tooling. So I'm going to do the same diameter, 0.875, and the depth this time will be from there to there. I'll apply and okay that. All right, so we turn, comes in and does the ID, drills the holes in the flange. Now you can see here, it's drilling that feature with the tool moving around the part. I'll come back to that in here in a minute. Then we're coming through, and so right now we're using static holders that are aligned to the setup that we have selected for that tool path. So a couple things we want to change. Well, actually, first thing I want to point out is just how it's cutting this flange. So if we look at this checkbox, or look at this right now, it is cutting using, it's not simulating that. Bore. I probably should turn some of this off. All right, well, if we were to do a machine simulation, I think we would see here, let's just run into a machine sim. I was going to save this till the end, but I think we'll see that the C-axis is rotating as we're cutting around this flange. All right, so here we got some issues with our tooling. So this is where I want to incorporate probably a tool where I can just index my bead sideways and come down a machine, which I was going to get to next. So let's eject that simulation real quick. Come in, we'll do that first, just so we can see what's going on here. So for the turning, I don't want to use my standard 80-degree tool. I want to come up and grab a holder that I can rotate with my B-axis and apply that. So I'm going to do that not only on the turning feature, but the facing. So I can use the same tool for both of those. So we'll apply, and actually let's get rid of, we don't need to rough and finish the face. Let's just do a finish pass there. And then on the sub-spindle side, we'll make those same changes. So I'm going to come in here and turn off rough pass and change my tooling to that B-axis tool. And okay that, and do the same on the turn, rough, tool, B-axis. Okay. Let's jump back in there to the simulation. I must not have okayed it. Third time's charm. But you can see how easy it is to move back and forth between toolpath and simulation. All right, there we see the B-axis head rotating, doing the turn feature. Then we come in with the boring bar. There we could see it. All right, so it is rotating the C and coming in with, so it's basically doing CX and or Y to machine that flange with polar interpolation. So if we wanted to lock that C-axis and just use XY, if our machine Y limits are large enough to accept it, we could simply come into there to that side feature, and they made this really easy in FeatureCAM to just say, hey, I want to use this with the Y-axis. And you can even specify a C angle if you wanted to. But now that we have that, we should see in the machine sim that the C-axis locks down and we cut with X and Y. Boring. There we see it. C-axis is now locked. So just like that with that checkbox, very simple and easy to make that change. All right, so last thing I want to show is a little bit of IFR, so interactive feature recognition. So we did not get a few of these features on setup one. So we got this cutout here, we got a flat on the bottom, flat on the top with a pocket and some holes along the side. Let's do we'll do this side pocket right here first. So I'm going to go into features. This time I'm going to do a milled feature. And we want this to be side, extract with feature recognition. And this is along the z-axis. I'm going to just select some sides. So I'm just going to pick these surfaces, add them, go to next, and automatically pulled in my depth. And I do want to give this the radius at the bottom of that pocket, which is an 1/8 inch, and we'll finish that. So there are all the toolpaths created to rough and mill that pocket with the radius at the bottom. And then we'll do the stuff on the around the setup Z. So mill, this time we'll do side again, around, and I'm going to just say normal to that flat, and I'm going to select those two sides, finish that, and we can give a quick preview just to make sure it cut to the correct side of the lines. That looks good. Okay, and that one needs to be patterned to the other side, so we'll just go ahead and while it's still highlighted, tell that we want to pattern it around the index axis, and there's going to be 2 instances of this 180 degrees apart. And then we want to do this pocket here, so I will this time switch to pocket with extracted feature recognition. That's the IFR, interactive feature recognition. Normal to the same surface we did last time. You could also specify the angle if you just wanted to type it in. I'm going to use select side surfaces again to pick that pocket, and I'm just going to draw a rectangle around it. That's going to grab those surfaces, add them, finish that. Okay. The last thing is the holes in the sides. So for that one, I'm going to use directed AFR. This one allows us to look at specific types of features. In this case, I only want to look at holes. And I only want to look at holes around my index axis. And I'm just going to say automatic because I've got a couple different angles here. And let's see how it does. So there it found, looks like all the holes that I wanted, which is excellent. So we'll include all those and finish. All right, now I can run a 3D simulation. And I think we've got setup 1 done. So there's our B-axis head coming in, our boring bar, finishing that, drilling. We're cutting with the Y-axis, milling the flats, cutting out the side feature there, and finishing with the radius at the end, milling the pocket, and drilling our holes. Then it's going to come back through. Actually, did I not change? I must not have changed my, yeah, I need to change my depth of cut for that second side. But otherwise, it looks pretty good. Yeah, you've already seen how to do that. I just come in and turn and change my spindle side offset. I can specify that same side we left off on and apply that. And then we can specify some part handling to transfer to the sub side. So for that one, I will go into, let's see, we want to make sure we're in setup 1. This is going to be a turn feature, part handling, and I'm going to do a cutoff. And so I want to transfer this to the sub spindle while it's doing that. 2.25, we'll pull it out 6 inches. And we just need to tell it where to cut. So that's going to be at the end of the part. And I might even go a little bit past there just to leave some room to face off and give a real nice surface finish on the backside. And say, okay. And that should do it for this part. So we do all setup 1. Parts it off, transfer to sub-spindle, then we come back on the other side with our B-axis. You notice it automatically oriented my tooling the other way. If for some reason I wanted to change the angle of how that B-axis is oriented, I could simply come into that toolpath and select the set B-axis tooling orientation and specify exactly what angle I want that tooling to come in at. but you notice it did a pretty good job of automating that based on my setup. And of course, with that simulation, I get all my G code as well. All right, so hopefully you got some knowledge about FeatureCAM in this webinar on using advanced turn milling features. If you have any questions, please reach out to us. Here's our contact information, and I will see you guys again in about a month for part 3. Thank you.